So when you press this in your calculator, you get just 45, which is equal to bt squared. Then when you look for bt now, it's going to be the square root of that. So square root of 45 is, of course, 3 root 5. So this is what you have. We have figured out what is the length of this side bt over there. We are still following the idea of being applying this one as the properties of kite. Now moving to the next one, which is probably the last one in this diagram. We have a situation. The situation is that write down the length of the radius of the circle passing through the point B, C, and T. This circle passes through B, C, and T. And since this one is a right angle, then therefore this one has to be the diameter, because this one has to be, since T is in the circumference of the circle, and this BC must be the diameter of the circle, because only the diameter that subtends 90 degrees in the circumference of the circle. So on that note, if this is the circle that we're talking about, and sorry, if this is a circle that we're talking about, this must be the diameter of that, because it subtends 90 degrees at the circumference of the circle. So in order for us to find the diameter, the radius of this, it's just going to be half of this length BC. So have we figured out BC yet? BC is equal to BA. Remember that adjacent side and a kite are equal to each other, which means this one is also equal to that one. So this one is also equal to 15 units. So which means the radius of the circle will be equal to 15, which is the diameter, then divided by 2, which is going to be 7.5 units. So we are done for this one. Remember just the properties of the diameter in a Euclidean geometry. So on that note, we are done for this one, and we are truly done. So let's get into the next diagram. The next diagram is now telling us another story, and fortunate enough, we're going to cover up everything in this diagram. So this situation tells us that C is a point on the x-axis. So this is C. A and B are the vertices of the triangle. So which is C, A, and B are the vertices of a triangle, as you can see. Then AB intersects the x-axis at E. So this line AB intersects the x-axis at E. So E is the x-intercept of that line. So we also have ABC, the angle ABC, which is this angle, is given as theta. Then this one BAC, which is BE, yes, BEC, which is this angle, is given as alpha. So this is the information that we have. So what are we having here? We have to calculate the gradient of AB. The gradient of AB, we've been calculating the gradient of 2 points. We probably know how to do it now. The gradient of AB is equal to y2 is 12 minus y1 is minus 3, then it's going to be plus, because minus times minus is plus, then therefore then x2 is 4, then x1 is minus 5, then minus and minus gives you a positive. So we have that one. So we now have, this is gonna be 15 over 9. So what 3 goes how many times to 15? 5 times. Then to 9, 3 times. So this is the gradient of this line AB. Done with that. Then moving forward, let's then find out the coordinates of the point E. Hence the gradient of this line is what? Is 5 over 3. Then therefore the coordinates of the point E. coordinates of the point E, we really need to figure out what is the equation of this line. So the equation of the line AB is given by mx plus c, and the m is 5 over 3 already, then x plus c. Then what are we having? We have this coordinate or this coordinate, doesn't matter, we can use any of them, but I hate negatives. Why can't I just use the coordinates of b? In the place of y, I will put 12. In the place of x, I will put 4. Then in the place of c, I will put c. Then therefore use my calculator and solve the solution there. What I have c being equal to 16 over 3. That tells me that the equation of this line is given by 5 over 3 x plus 16 over 3. So this is what I have, but I haven't answered the question yet because I'm looking for the coordinates of E. It's probably 3 or 2 4 marks. Then therefore, what do you know about coordinates E? You know that y0, it's only the value of x that is unknown. So in the place of y, I will put 0. Then therefore, knowing that I'll be having only one unknown x in this case, then therefore solve it. And when what I have negative 16. I have 5 over 3. X is equal to negative 16 over 3. Then x is going to be equal to what I have, negative 16 over 3, then times 3 over 5. So it's going to be negative 16 over 5. So this is right what I have. So the coordinates of E is negative 16 over 5 is to 0. So this is what way to calculate the coordinates of E. Then moving forward, the situation tells us that we are to find the size of alpha. This is the size of alpha, which is of course the angle of inclination in this line. The angle of inclination is this one. To find the angle of inclination, you really need to know the gradient of this line. Of course, we know it. What is it? It's 5 over 3. So now, to find the angle of inclination, we are going to say tan alpha, which is the angle that we are looking for, is equal to 5 over 3. Then therefore, whatever angle that we get there is going to be then tan inverse of 5 over 3. So in your calculator, you have that button. By pressing shift, then you press tan, then you press 5 over 3, you get what you call, this is just 59, you to the nearest whole number, this is 59,036, then to the nearest whole number, this is just gonna be 59 degrees. So this is the angle alpha. Done with that, because of course this is an angle of inclination. This is of course how to find the angle of inclination. Moving forward, we also have another situation that if this angle is given as 76, now determine the equation of the line through A and parallel to BC. You just need to imagine this line. How is it gonna be like when it is passing through A and parallel to BC? So the line that is parallel to BC have to slant this way because they have to have the same slope. So this line is now parallel to BC. So now what are you looking for? You're looking for the equation of this line. And it is given that this is 76 degrees. We don't know where is it going to help us, but we know for sure that somewhere, somehow, we are getting there. Now, what do we do? The idea is to know that if this line is parallel to this line, we know that this is equal to that because they are of course alternate angles. So what are we having? We have this being equal to 76 as well, if this one is 76. If this one is 76, and this one we figured out that it is 59, and if that is 59, and this one is also going to be 59. This one is also going to be 59 because these are the vertical opposite angles. This angle is 59. This one is also going to be 59 degrees. Then if that's the case, we can figure out this angle. We can figure out what is this angle. This angle over there, you can see that if you are having, this is 59, this is 59, and we know that this K thing is the exterior angle of this triangle, which is blue over there. So this is an exterior angle, and you can see now that K is what? K is equal to 76 plus 59, because exterior angle of a triangle anyway. So K is equal to 76 plus 59 gives you 135. So 135. So you can see now that since we're having this one, tan 135 is -1. So the gradient of this line is actually -1. So the gradient of the gradient of B, C is equal to the gradient of this new line. And they are both equal to -1, because we turn that angle, tan 135 is equal to the gradient. It is -1 equal to the gradient, because now you have to use the angle of inclination to find the gradient. When you are looking for the angle of inclination, you use the gradient. You just have to use the vice versa of the other if the other one is given, because they are inverse of each other. Now, having the gradient of that line, you are now there because you are looking for the equation. So y is equal to the -1 x plus c. Now what do we do with that? We are going to use the point A, because this line is passing through point A. So when it's passing through point A, we have to use that line, that point, because if there was any other point that was given at this line, you would use it. But you cannot use the points in this equation, because we are not looking for the equation of this line. We are looking for the equation of the line parallel to this line. So we just need to know which coordinates must you use when you're looking for what. So on this note, the coordinates of A is in the place of y we put -3, then this is equal to negative. In the place of x, what do we put? We put -5, then therefore plus c, then your c is going to be equal to, this is positive, then we have -3, then minus 5, then your c is going to be equal to -8. So of course your graph, if the line would continue that way, your coordinates of c would be negative there, and of course it's just equal to -8. So the equation of the line is -x minus 8. So this is the equation of the line which is parallel to BC, which is just the question that needs more of the application, but nonetheless we managed to get it all. Then let's move to the next diagram. Now, if you don't have a question for this one, let's move to the next diagram. The next diagram, we are having something like a situation. In the diagram, A, B, and C are the vertices of a triangle ABC. M is a midpoint of AB, and N is a point on CA such that MN is parallel to BC. So let's have a look. What does this situation have with us?